Hello everyone, welcome to Maths IUC. We are going to look at another exam question on electricity. A student wants to investigate the relationship between current and voltage for a filament lamp by plotting a graph. Their teacher provides two different circuit diagrams that could be used to carry out the experiment. Circuit 1 includes a potential divider to change the voltage across the filament lamp. So you can see there's a potential divider here. You can connect the sliding contact to any place and get a certain amount of voltage. That's one way. Circuit 2 uses a variable resistor in series with the bulb. So here's the bulb, here's a variable resistor in series. So you can change the resistance of that. That would change the voltage across it, and it changes the PD across the bulb. Evaluate how suitable each circuit is for collecting accurate data for the current voltage characteristics of the filament lamp. Now, both of these circuits are used, can be used, and they are both used in a kind of a similar way. So all we need to do is we need to get a series of voltage and current readings. So to produce a graph, you need a minimum of 6 pairs. So all you need to do in the first one, you can change the position of the sliding contact, which changes the voltage across the bulb, which changes the current in the circuit. So you can get the data. The second one, you can change the size of the variable resistor R, and you can do the same thing. Now, we need to think about the points that you can write. To compare these two, you need to tell like pros and cons of these things and how suitable each circuit is. So they're not really asking you to choose one. You can probably just explain pros and cons of both. So pause the video and give it a try. When you're ready to check the answer, press play. Now, the first thing that we can mention is that both circuits are suitable as they both allow to measure voltage and current. Now, the next point is in circuit 1, the minimum potential difference is 0 volts. Now, how can you do that? All you need to do is connect the sliding contact all the way to the starting point here. So there is no potential difference, that's 0 volts. And the maximum is the total voltage of the battery. So if you remove this and connect it to the other side, like to this end, then you get the total voltage across this one. However, in circuit 2, the minimum voltage is more than 0. Now, why is it more than 0? Because to get the minimum voltage across the bulb, we need to give the maximum voltage across this one. So how do you get the maximum voltage? You increase the size of this resistor to the maximum value. Now, imagine this is 10 volts. This will take, at maximum, it might take, I don't know, let's say 9 volts, 9.5 volts. However, the bulb will still get the remaining 1 volt. You cannot really make it 0. In the first one, if you connect it all the way to the starting point, you can make it 0. But in the second one, you cannot. And the maximum voltage is less than the EMF of the battery, as the resistor always keeps a proportion of the input voltage. Now, if you want to get the maximum PD across the light bulb, what you need to do is you need to slide the variable resistor to the lowest possible value. But still, it has a certain value. So this might keep, I don't know, let's say 1 volt across it. So the other one will have, the bulb will have 9 volts. But that is still less than the EMF. EMF is 10. The bulb will never get 10. It will get a large proportion of it if you really reduce the size of the capital R, but not the full thing. So that's why I said more than 0, and the maximum voltage is less than the EMF, as the resistor always keeps a proportion of the input voltage. In circuit 2, the total resistance of the circuit can be changed by adjusting the variable resistor. So the minimum voltage that can be provided to the bulb in circuit 2 depends on the size of the resistor. So that's kind of connected to the previous point. So depending on how small you can make it or how big you can make the value of capital R, the PD that you can provide to the light bulb changes. So to finalize it, we can say in conclusion, a wider range of voltage variation can be achieved using circuit 1, which would be more versatile. Now for 6 marks, we can talk about that both circuits are suitable. We can talk about in circuit 1, the minimum PD is 0 and the maximum is the total voltage of the battery or the EMF, provided that capital lowercase r internal resistance is 0. Then in the second one, the minimum voltage is more than 0 and the maximum is less than the EMF. And then in circuit 2, you can change the voltage, change the PD across this one by adjusting the variable resistor, and that it is dependent on the size of the resistor, and then you can come up with the conclusion. So any 6 points out of this will get you marks for a question like this.